So a lot of you have probably heard of something called the video element, the HTML5 video element, and I'd love to talk about that for a bit because this is often the starting point for web developers, for front end developers when it comes to video. The way that the HTML5 video element itself has evolved is super interesting. It's evolved in a very different way, really, to if you think about like the image element, right? It's evolved in a very different way. The video element kind of exists for some incredibly basic use cases, and kind of for anything more than a super basic use case, the world kind of starts to go away from you when you're using the video element. So the video element is capable of just downloading a file progressively and showing it to a user. Now, that's fine if all you want to do is show like a really short clip, or maybe if you want something looping, or you want to do a design asset where maybe you've got this big video sitting behind the kind of hero of your website, as it were. That works kind of fine, but there are sacrifices with that, and there's two sacrifices really, and it depends on whether you've got great bandwidth or poor bandwidth. With just using the video element with one single quality video in it is going to either cause buffering for some users who don't have a network connection that is good enough to watch that video, or it's going to mean that some users have a much better network connection and they aren't going to maximize that network connection. Now, this in the video world is considered a pretty well solved problem already. We call this adaptive bitrate, or ABR is the other three-letter acronym for it. And there's a couple of commonly thought of specifications for adaptive bitrate. One of them is HTTP live streaming, one also known as HLS, and the other is MPEG-, so that's dynamic adaptive streaming over HTTP. There are a couple of other fringe specifications or older specifications out there, but these are kind of the common ones that you see on the internet today. Now, one of the other challenges of the HTML5 video element, just as a kind of pure video element, video struct equals a URL, is that that doesn't really work for live streaming in a majority of the browsers. The HTML5 video element actually has really different capabilities depending on if you're using it within Safari, or if you're using it in Edge, or if you're using it in Chrome, for example. For example, Safari can accept a live stream right in your HTML5 video element. It'll work just fine, but that won't work in Chrome. Maybe we could look at an example of that. We've got a bit of time, so let's have a look at an example of that. I'm going to share a screen. Hopefully I'm going to pick a good one. Let's go with this screen. Cool, brilliant. James, can you see a screen?
I can see Phil's players.
Cool, brilliant. I'm not actually going to use Phil's players. I'm going to go to Code Sandbox. I'm going to create a sandbox, and I'm actually going to do the most boring static site sandbox possible. Okay, so I've got a web page. Is the font size okay? Yeah, it looks pretty okay.
Looks good to me.
Can't really see much of it. I'm going to slide the page off here. As an example, I'm going to do something really boring. I'm going to get rid of a header. We're going to use that video element I talked about. Video / video. I'm just going to give it a width of, let's say, 500, and a what should we put else? Let's give it controls as well. Cool. So if we look on the right, we've got a video player now. It's got some controls on it. It can't really do much. We need to give it a source, right? So if we do the same as we would do with an image, let's say, I'm going to pick and jump this over here so I can find a source file. Okay. HTTPS:// and then just a MP4 video file, right? This is the most basic you can imagine that you can do with the HTML5 video element, right? So if we reload that, we might even get it to play. Oh, it doesn't even play. Oh, that's no good. It really doesn't work. It should work. Wow, File doesn't even work. Wonder why that doesn't work. Let's have a reload of the network and see what happens. Yeah, well, no idea why that doesn't work, but it isn't even loading my MP4 file. That's really nice of it. Well, that was a great starting demo. Video controls source equals, we've got a bad URL in there, that's why. Wow, there we go. Should be easier to see. There we go. Perfect. So now we've got just a really simple video element in our website. If I was to like throttle down my internet connection, that's going to load really slowly, right? So if we load this is what I was talking about earlier with needing kind of this adapted bitrate technology I mentioned. If we throttle this down to let's say slow 3G and reload it, we're going to see it's going to take forever for this file to once this loads. It's going to take a while probably. Hopefully we've got caching turned off. Let's see if we can even play this. Oh, we can actually play it. I was surprised. Oh, there we go. And we got a buffer event because we haven't got enough bandwidth. And then it's probably going to kind of buffer forever, even on this network connection. So we kind of need something that can can deal with that sort of situation. Now, we could use adaptive bitrate technologies to do this, but the big browsers, Chrome and Firefox, don't actually have a way to do this using a HTML5 video element. So one of the most popular protocols for doing streaming on the internet is called HLS, as I mentioned, HTTP live streaming. This is a technology developed by Apple, and it's kind of how we at MUX deliver all of our content, whether that's live or on-demand content. What I'm going to do is show you kind of what that looks like as an example. So the way we're going to take a look at that is we're going to pull up a video player. Now, this is a bit of a more advanced video player. It looks just the same as a HTML5 video element because it's got no styling around it. But what we're going to do is load up some video content in here and watch it play. So load up my HLS manifest. And we're going to see a nice little video of a bunny having a really bad time. It's my favorite video in the world. I don't watch any of the videos in this anymore. And I don't know if you noticed, but the quality started off pretty low and then suddenly improved, and it's still improving, actually. That's an artifact of using HLS to play back this content. If we take a look in the page and reload this player, I'm just going to make my network inspector a little bit bigger. I'm going to reload the page, clear my buffer. I'm going to hit load demo HLS manifest. We'll see a bunch of requests happen. I'm going to mute this again. We'll see a bunch of requests happen. So video is actually a really chatty protocol. In this case, we saw this M3U8 request. This is what's called a master manifest request in HLS. What this contains is a list of all the different qualities of video that are available. So in this case, that is 145 kilobits a second, 365 kilobits a second, 700 kilobits, 1,100, 2,000, 3,000, 4,500, and 6,000 and 7.8 megabits as well available. So we've got lots of different qualities of this content available. If we look at kind of the journey that this live stream, this video file took, it went through the 145 kilobits a second as it first started and jumped up to 1 megabit, 3 megabits, 6 megabits, and all the way up to nearly 8 megabits. This was just a player starting up, getting used to a bandwidth I had available, and then adapting accordingly. If we redid this, for example, and let's drop ourselves to fast 3G, it's a little bit more reliable. Reload this again. Clear out all our request mess. Play it again. It's going to take a while to start up, but it will play, and it'll play consistently. But it's going to stick on that low quality, right? It's going to stick about 365 kilobits a second. If we remove this throttler, we'll actually see it suddenly jump up to much higher qualities again. There we go. It's jumped up to the 700, 1 megabits, and then it'll work its way up. It might run out of time on the video before it's worked its way up all the way to the top. Only made it up to 2 megabit in this case, just because it didn't have enough time to watch the whole, to see the network increase to its full capability. So this is using a technology called HLS.js. What this does is it takes that HTML5 video element that we've talked about and adds a capability to play HLS videos inside that video element. We can totally look at all these files. For example, if we take this URL, pull up a terminal, going over here, right over here. If we pull up a terminal, this isn't really any deep magic, right? We can just curl these down and we'll look at these manifests and we can just see them right there. So then we've just got this list of different qualities. So if we wanted to look at that first one, what we do is modify the URLs, make a relative URL and pull down that manifest. And this manifest just lists a load of segments. So when you're encoding video for delivery over the internet, what you do is you chop it up into lots of little bits, and then the player can switch between those little bits and put them back together to make your playback experience. These are just transport stream segments. They could also be little MP4 files or kind of anything else in between, really. So this is a really simple protocol that is pretty well understood in the industry, developed by Apple, and this can get you kind of near ubiquitous access to devices. This can work on kind of an iPhone, an Android phone, on web browsers we just showed. Now, you can do the same for live streams, which is really cool. The technology expands for both. If we look at this list here, we have an end list at the end of this live stream, at the end of this manifest. And if there wasn't one there, then the player would be treating this as a live stream. So this is why it's called HLS. The L is for live. It's also used for on-demand streaming, but it doesn't necessarily have to be on-demand or live streaming. It could be either. It can kind of be both as well. You can create kind of this rolling window, which is pretty cool as well, of live and on-demand content. So let's take a look at what this looks like for a live stream, because it's kind of interesting. I'm just going to fire up a live stream really quickly. On my end, I just opened up an encoder on my end. I'm just going to really quickly create a live stream. How's your day going, James?
My day is good. My day is good. It's interesting to talk about the players starting up. And, you know, in this example, we started on the lowest quality to get the quickest startup time. But there's an interesting debate there in itself for, should you wait to have slightly better, have a slightly longer startup time for the video, but get a better quality from the word go? Or do you want a really quick startup time with a lesser quality in the hope that the network conditions kind of improve as time goes on? So I always think that's an interesting debate. No one seems to have like a really, really good answer to that. I don't think. It's kind of just depends on what you want the experience to be.
Yeah, totally, completely agree. That is a super interesting question that everyone really makes different choices on. The best platforms out there kind of don't end up making that trade-off, right? Netflix are lucky enough in the infrastructure and the amount of money they have, such that they can optimize for both of those. But yeah, in a generalized world, yeah, it's really hard to optimize that combination of things. I've spun up a quick live stream. I'm going to reload my player. I'm just going to use the same player. And I'm going to throw in my live stream URL. I'm going to try left my network problem. There we go. And we've got a guy dancing my live stream. Oh, we've got a little bit of buffering there. So yeah, there's a quick live stream running. Now, if we take a look at what's happening when this live stream's running, it's really interesting. We've kind of got the same stuff going on, but we're going to have to constantly look at that manifest file we looked at to see if the list of segments have changed, so that we know if we need to go and get another segment. So if we look at rendition.m38 in here, we'll see that this is requested every couple of seconds to see if it's changed. There we go, keeps happening again and again. And then if we just look at .ts segments, again, we'll see these coming in every couple of seconds. And roughly speaking, we poll the manifest at an interval that's about half the duration of the segment. So in this case, we can look at how long the segments are actually, rather than guessing how long the segments are. We can look at how long the segments are. Oop, I pasted the wrong thing out of my buffer. There you go. I'll go back and grab it from this buffer. There we go. If we take a look at this manifest, this is just a slightly more verbose manifest than the last one. And we take a look at the rendition manifest for it. There we go. We can see this list of segments that we've got, right? So the interesting thing here is this, right? This extinf tag. This is telling us how long the segment is. So in this case, we know the segment's going to be 4 seconds in duration. And the most recent segment on this was segment 32. If we ask that same manifest again, we've probably got a couple more segments in them. So we've actually got quite a few more segments since then. If I wait a couple of seconds, 37, 38, 39. So we're still building out segments every 4 seconds here. So we need to poll that manifest at least kind of half of that period. So we'd expect that manifest to be polled every 2 seconds to be able to keep up to make sure we're always got enough buffer. And buffer's really important here. So when we consider building video systems, and particularly in the browser, what you always think about is how big do you want your buffer to be? So how much resilience do you want built into your system? So, back in the early days of watching videos on YouTube, right, it was common to, certainly in my university dorms, it was common to start a video playback and pause it and wait for it to buffer a load, then unpause it so you could watch the video uninterrupted. I think YouTube have actually now stopped fully buffering a video. Back in the day, you were certainly able to buffer the entire video and then just play it. I think now they're kind of limiting that to 10 to 30 seconds, I think. And again, this is kind of an active choice you end up making when you're building video systems in the browser. Now, the way that tools like HLS.js work, and HLS.js is what we've got here, they're really simple. So in this case, HLS.js is really just a polyfill. So it's adding HLS capabilities onto the HTML5 video element that it doesn't otherwise have. This uses technologies called media source extensions. Oh, I got money saving expert rather than media source extensions. Wow. This uses technology called media source extensions. So media source extensions is a API to the lower level handling of media within the browser. So in this case, what's happening is you kind of got a fetch request, fetching these segments, churning these segments. In this case, because one of the biggest challenges is the browser can't actually play those transport stream segments. They actually have to be transmuxed in JavaScript into a different format, into an MP4 container, so you can address that with the Media Sources API. Now, what's really interesting is if we took like these HLS URLs, let's pull one up here. Let's use my live stream URL from here. If we just put this into the URL bar in Chrome, this just isn't going to work. It's actually going to try and download it. But like I said, different browsers disagree on this, right? So if we fire up Safari, Safari can totally natively play back this M308 URL. My internet connection is not great today. There we go. We've got our dancing guy back. But yeah, Safari can totally play this. This is just kind of part and parcel of that HTML5 video element, the capabilities across browsers not being consistent. You can actually see in Safari, because it's playing it natively, it's actually switching the size of the viewport when it switches rendition to be able, rather than just kind of holding it, wow, that was a glitch, rather than just holding it in one visual size. It's really cool. So let's get rid of Safari again. I noticed a question in Discord, so I'm going to jump over. I have a question. Is there a possibility to use WebSockets or long polling these requests if they are too much? Yeah, absolutely. Really great question. Really great question. These technologies kind of predate a lot of those technologies existing. HTTP live streaming, HLS, MPEG-, all those sorts of things really do predate a lot of these web technologies. Now, as such, they weren't really designed for kind of things like long polling. This is changing a little bit at the moment. So there are a lot of alternate strategies that have been around for a while to use things like WebSockets to deliver live streaming video to reduce latency significantly. The challenge is, the great advantage of things like HLS and MPEG- is that you can use them with commodity HTTP servers and commodity content delivery networks like Akamai, CloudFront, Fastly, Limelight, you name it. They just kind of work. It's just a HTTP request. So when you're at high scale, you want to be able to use that commoditized approach, that commoditized hardware. Whereas a lot of those approaches, kind of long polling and WebSockets, aren't as available on large scale CDNs. one of the big challenges in the video streaming industry at the moment is reducing latency. And when we say latency, we're measuring generally what's called glass to glass latency, where that's the glass of the camera, be that on your laptop, or your iPhone, or your professional video camera, to the glass of your screen. Now, historically, live stream latency has been relatively high, 20 to 45 seconds. Now that's starting to come right down. On our platform, we're somewhere in the region of 10 to 15 seconds for our reduced latency live streams. But platforms like Twitch and Periscope do achieve kind of much lower latencies. And they achieve those often through a combination of technologies, usually using HTTP chunk transfer encoding. So for those of you who remember very early the HTTP1 spec, this was a mode where you can send partial HTTP responses before you know the content length of them. And we can actually have a look at that happening on Twitch. It's super interesting, but this is one of the ways to achieve low latency live streaming. A lot of people have yet tried using WebSockets for that, and long polling. There is kind of a little bit of this happening. There's a new specification from Apple for ultra low latency HLS live streaming, which gets to a region of 2 to 5 seconds, glass to glass latency. And that actually works by leveraging kind of pieces of long polling. For example, sending a manifest request that blocks until that updated manifest is available is one of the things that is included in that new specification. That specification has been super interesting because it originally was very heavily based around HTTP2 push. And there was a lot of feedback from within the industry that the world wasn't really ready for that yet. I have some blog posts I'm more than happy to share later if anyone's interested, but that is one of the challenges that came with that was you just can't really do change HTTP2 push on public CDNs today. So that eventually got dropped and got replaced with mandatory HTTP2, but without a push element to it, and with some super interesting other mechanics to kind of emulate things like long polling and that sort of thing. It's just super interesting. If you're interested in looking, you can often look at like high-end websites. Let's pick up a Twitch stream, see who's live on Twitch. I don't know who I'm signed into Twitch as. I'm signed into Twitch as DMUXed. So let's pull up a stream on Twitch. I don't know who this is, X2 Twins, whoever this is. And what I'm going to do is turn on, come on Twitch. I'm going to turn on, I'm going to mute, and I'm going to turn on Twitch's video stats, hopefully. Here we go. So what we can do, this is a really interesting thing, and you can do this on lots of websites, but we can look at, for example, the buffer size that Twitch has right now. It's currently running 11 seconds, and it's in low latency mode. And now it actually hasn't truly entered low latency mode, because the low latency mode should bring it down quite a lot lower. But currently this is, they're reading the latency to broadcaster as 11 seconds. Now, what we can actually do is we can look at all the stuff that we just talked about happening in Twitch's console, right? So if we filter for M3U8 in here, we'll see manifest requests happening, right? We can see Twitch are using HLS as their technology here. And we can see in these lists, we can see segments. Now, the interesting thing is Twitch have built their own variant of a low latency live streaming technology that allows prefetching of segments, that uses this chunk transfer encoding that I talked about earlier to improve the latency by pulling partially incomplete segments down. So you can see it's happening on most popular video websites. Sometimes it won't be HLS. Some of the more mature websites have moved away from kind of the established standards like HLS or Dash, and moved into kind of either their own manifest formats or moved into kind of a manifestless format. But what you will see consistently, even on things like Netflix and YouTube, is these segments coming down. If you pick a video, you'll see these periodic loads of segments. And if you scrub deep into a video, kind of jump late into a video, you'll see a sudden burst of network activity as the player has to request more media segments there. We've got about 5 minutes. That was a really crash course in video streaming, and particularly video streaming into a JavaScript or browser environment. Some of the tools you might be interested in looking at if you're ever interested in doing any video streaming is things like Video.js, which is a more complete player framework you might be interested in. I do love this video of the little girl with her unicorn, and we have a variety of other videos, City, for example, which you might recognize from my other live streams. And this is a super customizable video player framework. And you might also want to look at, yes, HLS.js, which is a framework for building your own players, which is really cool. We have a website called howvideo.works. And How Video Works is an information site which talks about the processes that underlie both live and on-demand video streaming. So we broke this down to 4 stages: capture, processing, delivery, and playback. We really talked about our playback element, a little bit of delivery and a little bit of processing, but really talked about a playback element, which is kind of how it interacts often in a browser environment. James, is there anything you wanted to ask or talk about? Oh, I'm sorry, I asked you to join me and then I talked for most of it.
No, it's fine. I'm conscious we don't have an awful lot of time, but how about going live from the browser?
Oh man, that's such a good question. That's such a good question. It's almost like I planted that question. I didn't. I
You didn't plant that question. I can confirm.
It's a great question. So as I said when I was spinning up my live stream, I had to spin up an encoder. I spun up an encoder called OBS on my local machine. You might have seen this before. I can switch between scenes in this. See to myself, hi guys, and I can add in little components. Like I could add in like my browser down here and stuff like this. This is my first stage encoder that I'm pushing my live stream out of. You need one of these if you're going to do some live streaming. But the problem is, like, especially in the market we're in, and as the world has changed with COVID, people don't necessarily want to install something or build out a first stage encoder. What they want to do is just go live from a browser. And the problem is you can't really do that right now. Generally, most platforms use a tool called RTMP to ingest the live stream as its first stage. That's what OBS is outputting. That's what Wirecast or any other of those streaming tools would, the first stage encoders would do. We've been experimenting with this. We want to make this easier. We want to make it super easy to go live from browser. We built a little tool called Wocket. This is a proof of concept where we're using WebSockets to pipe the data out of the webcam or the screen share of the user and send it down into a kind of edge compute deployed FFmpeg instance, which is then converting that WebSocket stream to RTMP and sending it on into a live streaming platform. See if we have an example of it still running. 50-50 whether this is still up and running. Oh, wow, it's still up and running, even better. It's a real bold one to see if this actually works. I'm going to spin up quickly a new live stream on my side. This will be amazing if this works. Run request, view live stream, grab stream key. Yep. Okay, I'm going to give Wocket access to my camera and give it a stream key. And I'm going to hit start streaming. It's connected. Boy, I hope I see a connected event on the other side. I do see a connected event on the other side. We're going to change our text to hi JSNation. Hey. And then I'm going to grab my stream from over here. Hopefully, yep, I'm alive. So, and there we go. We can pull over our live stream that is just being broadcast on a browser for a relay. If you want to know more about this, Matt is doing a lightning talk about this later today. I will have a look what time it is, but yeah, Matt McClure, catch him on the main stage at, I don't remember what time, but yeah, he's going to show off some of the more technology we've developed around going live from browser. Here, I'm going to find it now. I don't know what time it is, but yeah, we'll be talking about this in more depth. Might even be tomorrow. I'm supposed to know this one. It's tomorrow, I think. But yeah, catch Matt McClure's talk on the main stage and you'll be able to understand more about how we develop this.